One of the four macromolecules are lipids, just like we had proteins and nucleic acids and carbohydrates. Most people think of lipids as being fats, but it's really the other way around. Fats are one type of lipids. And so we're talking about waxes like candle wax and sterols, cholesterol, fats like good old butter down below there, or oils, and vitamins. There's a lot of vitamins. I think it's something like D, E, A, K are the fat-soluble vitamins. Well, one of the differences between the two is that fats are solid at room temperature and oils are liquid at room temperature. So over here, we've got a lipid, butter, and this is also a lipid, olive oil here, but one is obviously a fat. That's the butter because it's solid at room temperature, and the olive oil here is liquid at room temperature. So we would consider that to be an oil. Okay, so what do lipids, what do lipids look like? So remember, we've talked about the way you make big macromolecules is you put little things together. So amino acids come together to form proteins, simple sugars come together to form polysaccharides. Same thing happens in lipids. In order to make a lipid, you have to put together small units. So this is an example of a type of lipid and the units you would see. Triglyceride. Why is it called triglyceride? Well, first of all, it's got a backbone here. This guy right here is the backbone, which is called glycerol. Okay, so that's glycerol there. And then you've got these guys over here that are attached to it. Now, these guys here are those pieces we're putting together here. So you can see that there's actually three long chains here. Those chains are called fatty acids. And there's lots of different types of fatty acids, lots of combinations. So those different combinations, like the combination of amino acids, would give us different lipids. In the case of a triglyceride, you have three fatty acids. You could also have a diglyceride or a monoglyceride with just two or one. And sometimes you have a different backbone here besides glycerol, could be something else. But basically it's fatty acids. That's going to be the small repeating unit. Now, I want you to notice something really interesting about these fatty acids. They look different. Now, a little bit of chemistry for you guys who are not familiar with it, right? This up, down, up, down, up, down, what exactly is going on here? Well, this is kind of a shorthand chemistry abbreviation. Every time you see a little angle there, a little vertex, that's actually a carbon. So these are all carbons here. And if you go down here, here's two carbons, but they're held together by a double bond. And this one actually has three double bonds in between the carbons. So carbon, 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 and there's hydrogens in there too. But some of them have all single bonds, some of them have a double bond, and some of them have multiple double bonds. What's the point of all that? Well, it turns out if it all has single bonds here, we say that it has as many hydrogens as possible. And we would call this guy saturated. Saturated means it has as many hydrogens as possible. This guy here doesn't have as many hydrogens as possible because instead of hydrogens, it has a double bond there. So we call that unsaturated. That's an unsaturated fat or an unsaturated lipid. And this guy has multiple double bonds there, so it's missing a lot of hydrogens. And we would call this a polyunsaturated fat. Okay? Let me say that again. Look at the fatty acids. If they're all single bonds, that means it has as many hydrogens as possible, and we say, therefore, it is saturated with hydrogen. If it has a double bond, that's because it's missing a couple of hydrogens, so it's unsaturated. And if it has multiple double bonds, we say it's polyunsaturated. Now, you've probably heard those terms quite a bit, and the reason why you've heard them quite a bit is that the saturation of a fat tells us how healthy it is. In general, the more saturated a fat is with hydrogen, the worse it is for our health. The more polyunsaturated it is, the better it is for our health. So let's just take a look at here. So here's some nice oils you can see, and the red here is the bad stuff, that's the saturated. But you can see that these oils, for the most part, are fairly unsaturated, so they're good oils to be using. But look what happens when you get into dairy products down here like cheese or milk or ice cream. Uh-oh, that's really bad. That's why it's so unhealthy for us to be eating that stuff. It's very saturated. Look at butter. Wow, that's bad. As compared to margarine, right? Which really is different. That really helps us off. And meats also tend to be fairly bad. They have a high saturated fat content in it. That's why they're so bad at causing things like colon cancer. Again, saturated means the number of hydrogens in the fatty acid. Okay, let's go ahead and summarize this stuff up. So what's the function of lipids? We've talked about that we are basically made of proteins, and we've talked about how sugars are basically for energy. What's the function of lipids? Well, I can think of three functions right off the bat here. They are also energy storage, but unlike sugars, these are a long-term energy storage. Unfortunately, I am carrying a lot of long-term energy storage in my gut right now. They also are great insulators, and we know this from animals. Blubber on whales and so forth is a great way to keep the heat in cold environments. And also buoyancy. Fat is lighter than a lot of things like protein. So when I was in high school, we used to say, well, are you a sinker or a floater? So if you get in the pool there and you find it easy to float, unfortunately, it's because you're a lot of fat. If you're really a good swimmer, very muscular and good condition, you got heavy, heavy tissue, and you sink right away. So sinkers were considered to be the better athletes. Let's go ahead and summarize it up. So let's do a comparison of lipids and carbohydrates in terms of energy storage. So let's do the lipids first. So lipids here, they contain more energy. You get more calories per pound in fat than you do in sugar. So it actually is better to be eating a candy bar than it would be to eat a big stick of cheese. Lipids are also lighter, and they're insoluble in water. They do not dissolve in water. So if you take a fat-based vitamin, you have to take it with something else besides water, or it doesn't go in there. Now this could be a good thing because a lot of molecules that are not soluble in water then will not affect a cell as regards to osmosis, so you don't have to worry about that. In comparison with carbohydrates, they are easily digested. They provide quick energy. So when guys are running the marathon there, and there's people standing on the side with cups, they hand them cups of Gatorade and so forth, sugary water. You don't get a big thing of olive oil to drink there, right? And carbohydrates, of course, sugar is very, very soluble in water, so it's easy to deliver, and it provides us with quick energy. And that is kind of my summation here on lipids.